Question number 9, and question number 9 is asked in 2012 NEET. Here we can see the acetaldehyde and the CH5CH2CHO can be distinguished chemically by. My dear students, it's a simple question when you know the concept of this question. My dear students, those aldehyde are ketones in which CH3CO group is present, or you can say CH3 CHOH group is present, or gives iodoform reaction, means these groups, my dear students, reacts with iodine and NaOH. When these groups are reacts with iodine and NaOH, to form iodoform, and this reaction is called iodoform reaction. My dear students, here you can see the acetaldehyde. Here acetaldehyde, you can get the CH3CHO. This is the structural formula of acetaldehyde. So you can get the CH3CO group in acetaldehyde. So this group, presence of this group is given as iodoform reaction. But here you can see another side, you can get CH5, here CH2CHO group, means both groups are not present in this compound. So my dear students, you can go the B option, here iodoform test. We can distinguish both by the iodoform test, and this question is asked in 2012 in NEET exams. Now my dear students, when we see the question number 10, which is asked in NEET 2011 exams. In question number 10, Clemmensen reduction of a ketone is carried out in the presence of which of the following? Here my dear students, what is the concept of this question? Concept of this question, you know the reagents. My dear students, if you know the reagents of Clemmensen reduction, then you can solve this question. So what are the reagents are used in Clemmensen reduction? Two reductions are here, Clemmensen reduction, in which zinc amalgam plus HCl is used, and number second is a Wolff-Kishner reduction, in which hydrazine NH2NH2 in NaOH we are used. My dear students, this is the concept. In this concept, you can see here different reagents are used in the different name reactions, but working is same. Those carbonyl compounds which are ketones are reduced by both reagents. This ketone is converted into hydrocarbon, means this oxygen is removed by the water molecule, and you can get this CO group is converted to CH2 group, and my dear students, it is called hydrocarbon, So we can reduce the ketones or carbonyl compounds, generally ketones, by both reduction process. So here in this question, which is asked in NEET 2011, answer is B, because it is a direct question. It is asked in NEET exams. Clemmensen reduction of a ketone is carried out in the presence of which of the following, that is zinc amalgam and HCl. Now my dear students, we go to the 11th question. The order of reactivity of phenyl magnesium bromide with the following compounds. Order of reactivity of phenyl magnesium bromide. Here it is what is the reactivity of this carbonyl compound. Here you might observe, my dear students, this is the carbonyl compound. Here CH3 and H group is attached. Here my dear students, here CO group is the carbonyl compound, and here you can see the two methyl groups are attached. Here this is the carbonyl compound, CO group is the carbonyl compound, and here two phenyl groups are attached. What is the concept of this compound? My dear students, when increase the alkyl group, alkyl or phenyl groups. When increase the alkyl or phenyl groups, reactivity of carbonyl compounds with any reagents carbonyl compounds decreases. Here you can see here acetaldehyde, you can get the only one alkyl group, here in acetone 2 alkyl group, but here you can get the bulky alkyl group, and it is also called benzophenone, because here phenyl group, when two phenyl groups are attached with this compound, then it is called benzophenone. So my dear students, reactivity decreases 1, 2 and 3. So answer for this question, that is D option is the correct answer. You can go to the D options. Now my dear students, we can see the question number 12. Which one of the following compounds will be the most readily dehydrated? It is asked in 2010 NEET exams. My dear students, dehydrated compounds. When this, you can see here, when for the dehydration, when OH group is gone, to positive charge is present on this carbon atom. When this OH group is gone, then positive charge is present on this carbon atom. When this OH group is gone, positive charge is present on this carbon atom. When this OH group is gone, positive charge is present on this carbon atom. Only you can see that which carbon atom positive charge is more stable. That carbon atom, positive charge carbon atom more stable are, my dear students, readily dehydrated. Here you can see this is this CO group, and this is the positive charge. Positive charge here, it is nearer to this CO group, and when this nearer to CO group, positive charge is present, means that is unstable, that create the instability, because here when this electron goes to this oxygen atom minus and plus charge, means already this plus charge is present on this carbon atom due to this mobility of this pi electron. Here my dear students, you can see here, this is the pi electrons gone to this oxygen atom, that's why minus and plus charge develop on this carbon atom. Here you can see, this is the electrons go to this oxygen atom, that's why positive charge develop on this carbon atom. So my dear students, you can see here, positive charge is present in this carbon atom, it is far away from this C, positive charge of this carbon atom, and due to this distance of positive charge, this is more stable, my dear students. So C is the most stable. C is the most stable among in this fourth example. And when this C is the most stable, then OH groups are easily go to the solution without any problem, because this carbon atom say, okay, my dear OH, you can go and enjoy in solution, and because I am stable. Now when we see the question number 13, which is asked in 2008, a strong base can abstract an alpha hydrogen from. But is the question, alpha hydrogen is removed from. My dear students, first of all, you can draw the structure. A structure of this A is CS3. If you can, ketone means acetone. First member of the ketone is acetone, my dear students. First member of ketone is the acetone. Then you can draw the first member of ketone, that is acetone. Number B is alkene. You can draw the alkene, that is CH2 double bond. Okay. B is the alkanes. Then you can draw the alkanes, and alkane is the CS3, and then you can draw this C part, and C is the alkene, that is CH2 double bond, CH2 alkenes, first member of this alkene, CH2 double bond CH2, and D option is the amine. Amine means CH3 NH2, it is the first member of amines, methylamine. Now we can see these four compounds structure formula. Now when these four compounds reacts with this base OH minus ions, here this reacts with base, here you can reacts with base OH minus ions, and my dear students, it is a strong base. It's a strong base means you can use the NaOH. Here you can use the NaOH strong base. Here you can use the NaOH strong base. Now question is that which alpha hydrogen is abstract or removed from this compound. Here you can see this is the functional group of CO. CO is the functional group. Here CO is the functional group, and these are called alpha and alpha dash carbon atom. Here my dear students, CH3 no function group is present, hence no alpha hydrogen atom is present here. So, this is no problem here, this is not answer because alpha hydrogen atom is not present. Alpha hydrogen atom is basically acidic nature. And what is alpha hydrogen atom, my dear students? Next, alpha hydrogen atom, and this is also a concept. What is the alpha hydrogen atom? My dear students, next carbon atom of the functional group. Next carbon atom of the functional group is called alpha hydrogen atom. Here my dear students, alpha hydrogen atom present in this compound, alpha hydrogen atom is present here. In this compound you cannot get the alpha hydrogen atom, no alpha hydrogen atom here, no alpha hydrogen atom here. So, it is not answer, no alpha hydrogen atom here, it is not answer my dear students. And you can get the alpha hydrogen atom present here because this is the functional group, and next carbon atom of functional group is called alpha carbon atom, and hydrogen atoms attached with this functional group are called alpha hydrogen atoms. Means if answer is this one or answer is this one, A or D, you can see only A and D, which is the answer of this question. Now we can see there in these questions, my dear students. A is a carbonyl compound, oxygen atom is more electronegative than nitrogen, and no pi electrons present in this molecule. Alpha hydrogen atom present, but no pi electrons are present in this NH2 molecule. Here you can see the pi electrons are present, and due to this pi electrons, my dear students, these pi electrons go to the oxygen atom, and oxygen atom get negative charges, and this carbon atom get positive charges. And when this carbon atom get positive charges, then bond present between the carbon and carbon, these electrons shifted to this carbon atom. Here these electrons are also shifted to this carbon atom because this carbon atom is now electron deficient carbon atom. And when these electrons are shifted slightly, then there this H plus, here H get partially positively charged, and when this H is partially positively charged, then here you can give this strong base. This strong base get this H plus ions and form this water molecule. So, in this compound, alpha hydrogen atom is easily abstract from this strong base. So, my dear students, answer is this question is, our answer of this question is, this is the A. You can go to A, question number 13. Now, my dear students, we can see the question number 20. Question number 20, which is asked in 2007 NEET exams. You can say the zinc amalgam concerned as Cl. My dear students, aldehyde and ketones are aldehydes. This is CO. Aldehydes are ketones, means this HH, yeah, CH3 are reduced by this zinc amalgam and Cl. In concentrated as Cl, we can get the CH2 group, means alkane. So, answer is the that is Clemmensen reduction. Because in Bulk-Fist reduction, my dear students, we can use the hydrazine in NaOH. So, now in this question number 14, you can get the answer Clemmensen reduction. Here if you can get the H and H, then here you can get the methane CH4. If you get this CH3 CHO, then this CH3 group is present. Here CH2 and H, means you can get the ethane C2H6. When here acetone is present in your compounds, then this acetone reduced by this zinc amalgam concerned as Cl, then you can get the CH3, CH2 and CH3, and this is called, my dear student, this is called propane T3H8. In this way you can see here 1, 2, 3. You can see here zinc amalgam in concerned HCl. These all are converted into methane, ethane and propane. 15th question, my dear students, the product formed in aldol condensation is a beta hydroxyaldehyde or a beta hydroxyketone. Which product is formed in aldol condensation? Now, my dear students, here aldol condensation, when you can get the reaction, in this reaction, my dear students, acetaldehyde CH3 CHO, this is the acetaldehyde, and another acetaldehyde is a CH2H and CHO. First of all, my dear students, both two molecules of aldehyde in presence of this base reacts with each other, means this H plus ions is go to this oxygen atom because it is a negatively charged and this carbon atom is a positively charged, and this negative charge on this negative charge present on this carbon atom. So, my dear students, you can get CH3 COH H and this CH2 CHO group. Here, my dear students, it is called aldol. Why it is called aldol? Because here you can see the aldehydic group and alcoholic group, OH group, are present in a molecule. Because here aldehydic and OH group present in a molecule, so it is called aldol. And when this aldol is heated, then H2 is evolved. But here in question, heating effect is not done. So, you can see here this is a function group, and after the function group, this carbon atom is called alpha carbon atom. This carbon atom is called alpha carbon atom and this is called beta carbon atom. OH group present on beta carbon atom is called beta hydroxy. So, this compound, this aldol is also called beta hydroxy aldehyde. It is called, my dear students, beta hydroxy aldehyde. So, you can go this is the first reaction in which acetaldehyde are used. When you can reacts with this acetone, two molecules of acetone, then you can get beta hydroxyketone. So, in question number 15, answer is, my dear students, you can must go the answer A, beta hydroxyaldehyde, and this is the reaction. Now, we can see the question number 16, nucleophilic addition reactions will be most favored in, and I give you the concept. What is the nucleophilic reaction, my dear students? Concept is that this minus charge is present, here plus charge is present. When this plus charge is more, means carbon atom is more electron deficient due to the attachment of that group which are electron withdrawing group. This electron withdrawing group are attached with this carbon atom or those groups which are electron attracting, then this carbon is a electron deficient and nucleophilic addition is favored. But when you can give the alkyl groups to this carbon atom, then this carbon atom electron deficiency is decreases. So, nucleophilic addition reaction is, rate of nucleophilic addition reaction is decreases. So, now my dear students, you can see here CH3, CH2, CH2 and here CH3. You can see here more alkyl groups are attached here. You can see two alkyl groups are attached. Here you can see two alkyl groups are attached. Here these alkyl groups are, bigger alkyl groups are attached. When alkyl groups are more, you can say when greater the number of alkyl groups, nucleophilic addition reactivity or reactivity of aldehyde and ketones, aldehydes and ketones aldehyde and ketones decreases. So here, my dear students, you go for the answer A, because in this acetaldehyde you can get only one methyl group. Here you can get 2 in ketone, 2 methyl and this propyl group. Here you can get 3 methyl group. Here you can get ethyl group. So lower alkyl group is A. So you can go to the answer A. Now, my dear students, when we see the question 17, the major organic product formed from the following reaction is. This question is asked in 2005. Here, my dear students, this CS3NH2. First of all, this question, and you can write here reactions. Reaction of this question. Okay, we can write here reaction. This is, my dear students, when this NH2 CS3, you can write in this way, methylamine. This is first reaction, methylamine. This methylamine, when this reacts with this ketone, because here methyl group is present, here methyl group is present. So this is the type of ketones. So this type of ketone reacts with amines to evolve NH2, and when this H2O is replaced from this, here double bond N and CS3 is formed, and when this compound is formed, then this compound is reduced by LiLH4, then this hydrogen atom is here and this here. So you can get, this is the NH and CS3, NH and CS3. In this way, you must be going in the this B option, because in B option you can get the same product in B option. Now, my dear students, we can go to the question number 18, and it is asked in 2003 NEET exam. Here CH3CHO plus HCN, to get this CH3CH OHCN and then hydrolysis to give this CH3CHOHCWH. My dear student, this is the lactic acid. This compound is called lactic acid. And my dear students, in this lactic acid, you can see here, this is the asymmetrical carbon atom. Due to presence of this asymmetrical carbon atom, my dear students, here you can see this carbon atom gives optical isomerism, and here racemization is also present. Half 50% of this compound is dextro form, D form, and 50% of this compound is L form. That's why you can see this answer is C, because 50% is D and 50% of L form is present. What is a D and L form? It is so the configuration. Now, when we can see that CWH, here C and H. Now, my dear students, 50% you can get this form, D form, D configuration, topmost, you can see the function group is present topmost, and here OH group present in right hand side, that is why it is form D form. And when you can see the optical isomerism of this compound, then you can get the, my dear students, this is the 50% of L form. In this way, both compounds are show optical isomerism. Because here this asymmetrical carbon atom is present. My dear students, what is the asymmetric carbon atom? Now we can give your basic point. That carbon atom in which 4 different group is attached with a single carbon atom. Here you can see this is the 4 different groups A, B, C, D are attached with a different carbon atom. That's why it is called asymmetric carbon atom. Asymmetric carbon atom. Now, our answer is C. Now, my dear friends, we can go to the question number 19, which is asked in 2003. Here, my dear students, all these, this is the reactions, and in this question says A and B in the following reactions are A and B. What is the A and B? Here you can see here carbonyl compound is present, and here this carbon compound oxygen get negative charge and carbon get positive charge. Here you can see here HCN H positive, Cn minus. So this minus ions attack on this plus. So you can get the RCO and R dash plus HCN. And by this HCN, my dear students, you can get the plus and minus charge, and this negative charge present on this oxygen atom, positive charge of present on this carbon atom. Then, my dear students, you can get the OH, Cn and R dash. When it is hydrolyzed by water or KCN, then you see the Cn group is converted to COH group. Then your compound is RC, COH, R dash and OH group. So, my dear students, when you can see this compound A, where this compound is present, here this A compound is present only A. You can go this answer, and after this B is the ammonia. When this compound is reacts with ammonia, then you can get this CH2 NH2 group, because OH is here and this ammonia is formed, and ammonia CONH4, here CuNH2 group is formed, and this amide group is converted to CH2NH2 group. So you can get this answer is A of this compound.